So this is part 2 of functions and change. In the last lecture we talked about how functions change. So we know that they either increase or decrease. They have relative maximums or relative minimums. And the way that they increase or decrease, they can increase in a concave up or a concave down manner. So they can either smile or they can frown. And then concavity leads to these sort of inflection points. So if you have a function and it's increasing, and so remember, it can either smile, so it can go up like this, or it can frown, so it can go down while going up like that. So the way we tell whether a function is increasing or decreasing, or concave up or concave down, one way to do this is to use the average rate of change. And so it's the change in the output of the change in the input. So last time we talked about how you can say the change in the y or the change in the x. If this average rate of change is positive, the function will on average go up. If the average rate of change is negative, on average it will go down. For concavity, we didn't really talk about how the average rate of change can be used to sort of measure concavity, but if you look over here, and so let's think about this. If you calculate the average rate of change between these 2 points, you're going to get a slope of a line. So the average rate of change is actually going to give you, in those 2 points, a slope of that line. Whereas if you take 2 different points, so let's take these 2 points here, you'll see you'll get a different average rate of change. So if you calculate the average rate of change between those 2 points, you'll get a slope of a different line. And what you want to notice is that the slope of the blue line should be less than the slope of the green line, because the green line is steeper. So what you can do is you can actually use the average rate of change to tell if a function is concave up. So for example, suppose you weren't given a graph, you were given a function like f of x equal to x squared. I can actually use the function and the notion of average rate of change to determine that this function is concave up. So that's sort of the significance of average rate of change, or one reason why it's important. So we did some of this in class, but today I really want to focus on, or in this lecture I want to focus on what's called the difference quotient. So the difference quotient is given by a formula. So here's the formula right here. I will not have you memorize this formula. For those of you going on to calculus, you'll see this formula used quite often. So the point of learning how to do this is to sort of prepare you for certain problems in calculus called, taking the derivative. All right, so this is really sort of an algebraic lesson, and so let's just do some examples so you can get an idea of what we're going to do here. And the first example we have is this f of x equal to x squared minus 3x plus 1. So we want to determine the difference quotient for the following function. So we'll start with this one, which isn't too bad, and we'll end with g of x, which equals 2 divided by x, which is a little bit harder because you're dividing by x. So let's start with part A here. And what I want to do is I want to compute the difference quotient of this function. So I want to find f of x plus h minus f of x all divided by h. So this formula will always be given to you. It's called the difference quotient. And you can understand why it's called difference quotient, because you're taking a difference here and then you're dividing, so you're taking a quotient. And I'll talk a little bit about where it actually comes from in a minute, but let's first use it. So what you have to understand first is that this function is really just a rule. Whatever's inside here, it says square it, take away 3 times it, and add 1. So on this part, whatever is inside there, so this is what's inside there. So the rule says you square it, take away 3 times it, and add 1. And so if you say it properly, you can actually do what it says. So it says square it. So first thing I will do, whatever's inside there, I'm going to square it. So I have x plus h squared. And then take away 3 times it. So then I'll take away 3 times it. It's whatever's inside there. So minus 3 times x plus h. And then you add 1. So this right here is f of x plus h. And then I'll take away f of x. And so this is f of x. So I'll take away, and make sure you put parentheses around it because you're taking away the whole thing. So take away x squared minus 3x plus 1. And then that's all divided by h on the bottom. So this says this, basically. There's a lot of simplification that goes on here, so I have to multiply x plus h squared out. So remember, x plus h squared is x plus h times x plus h. So when you multiply this out, you're going to FOIL, just use the distributive property twice. So it's going to be x times x plus x times h. So I have x squared plus xh. Then I have h times x plus h times h. So I have another plus h times x plus h squared, which is really x squared plus 2xh's, because hx and h are the same, and then plus h squared. So this would be equal to, I have x squared plus 2xh plus h squared, and then I'm going to take away 3 times x, so I have minus 3x, and then minus 3h, and minus times a plus is minus, and then plus 1, and then I'll distribute this minus sign through this expression, so I have minus x squared, a minus will give me a plus 3x, and then minus a plus 1 is a minus 1. And again, this is all divided by h. And now lots of things are going to cancel, so let's take a look and cross off the things that will cancel here. So I see I have an x squared here, so I have plus x squared and minus x squared, so they're gone. I have a minus 3x and a plus 3x, so they're gone. And I have a plus 1 and a minus 1, so those two things cancel out. So what am I left with? Well, I have a 2xh plus an h squared, and then minus a 3h, and this is all divided by h. So what I have, this is what I have left right now, and I'm almost done. There's one more step that I can do. Each of these terms on top has an h. So what I can do is I can actually factor out the h, and then you'll see that the h on top and h on bottom will actually cancel. So let's play this game where we factor. And so this is equal to, I'll pull out an h because each of these terms has an h in common. So I have h times something plus something minus something else. So here, something goes here times h gives me 2xh, so I need a 2x. Something goes here times h gives me h squared, so I need an extra h. And then something here times h gives me 3h, and so I'll put a 3. And then this is all divided by h. So now I have an h on top, I have an h on bottom, so then I can cancel off the h's. So h's cancel. And I'm left over on top, this is equal to 2x plus h minus 3. And that is my answer. So the difference quotient of this thing is this, 2x plus h minus 3. Let's take a look at our second example. So I have g of x equal to 2 divided by x. So for this one, let's write down the difference quotient. Instead of f, we have g. So instead of writing f of x plus h, I'll write g of x plus h minus a g of x, all divided by h. And so what is that thing going to equal? So let's draw a line here to separate what we're doing. So this is going to equal, so we need to do what it says. So remember, g is a rule. What's the rule? Whatever's inside here, it equals 2 divided by it. So now remember, what's the it? This is the it. So whatever's inside there, whatever the it is, you do 2 divided by it. So let's write that down. So g of x plus h, that's what's inside there, that's the it, so it's 2 divided by it. So 2 divided by, and it is the x plus h. So 2 divided by it. Minus, g of x is just 2 over x. And then this is all divided by h. And so now we're going to have to simplify here. Now to simplify, you're subtracting two fractions. So remember, when you subtract or add two fractions, you have to find a common denominator. At first it seems like the common denominator may be hard to find, but if you think about how common denominators work, so suppose you had, let's do like 3 over 4 minus, let's do 2/5. So to find a common denominator here, all you really need to do is multiply the 4 by 5 on top and bottom, and then multiply the 5 by 4 on top and bottom, and you'll get a common denominator of 20. So you're going to do exactly the same thing here. So here you just multiplied this by the 5 and then this by the 4, so you just multiplied this by the x, so we'll have x on top and bottom, and this one we'll multiply by x plus h, right, the other one. And then let's extend this and put an x plus h on top so you don't change the fact that this fraction is 2 over x. And so now you have a common denominator, so now you can add or subtract the numerators. And so you have 2x minus 2 times x plus h, all divided by x times x plus h. And this is all divided by h again. And so then we can simplify this by distributing through the 2 here. And so this would be equal to 2x minus 2 times x minus 2 times h. And then I have x times x plus h. Leave this x times x plus h alone down here. Don't multiply through by x. It'll make things harder on you. And this is all divided by h. And then notice what cancels on the top? Those 2x's. So you have plus 2x minus 2x. So they're going to cancel. And you'll be left over with minus 2h on top. That's divided by x times x plus h. And then the bottom, you have this divided by h. So we're almost done. The next step is you have to realize that when you divide by h, it's really a fraction, h over 1. And when you divide by a fraction, you multiply by the reciprocal. So 2 divided by h, or negative 2 divided by h, divided by negative 2 times h, sorry, divided by x times x plus h, then times the reciprocal of h over 1 is 1 over h. And the reason I'm doing this is because then you realize that yes, I have an h on top and I have an h on the bottom. So what happens to the h's? They're going to cancel because they're multiplying here and you're multiplying down here. And so this will equal negative 2 over x all times x plus h. Okay. So this one's quite difficult, and the issues that you're going to have are the same issues you have with adding or subtracting fractions. So we need to make sure that you understand how to add or subtract fractions. And if you feel comfortable with that, then we can get you comfortable with this. So real quickly, let's talk about actually why or what's actually going on here. So we have this idea of the difference quotient. And maybe I can explain to you some way why it is actually important. So the idea is you give me a function. So let's just draw any old function here. So here's a graph of a function. Let's call it f of x. And the difference quotient is given by a formula. The formula is f of x plus h minus f of x divided by h. And I claim that what this actually is, that this is just a generalization of the idea of average rate of change. So this is just like the average rate of change. It's just hidden in the formula. So this is my claim. It's like the average rate of change. To see this, let's take a couple of points. So let's take a point, an input we call x, and over here we'll take an input we call x plus h. Now if you take these two input values and you plug them into this function, you're going to get out a height here. And the height for this function then, if you plug in x, you get out f of x. Whereas if you plug in x plus h to the function, you get out a different height, which is called f of, well, your input's x plus h, so f of x plus h. And so you have input, output, input, output. You can even write down the ordered pairs. If the input is x, the output is f of x. Whereas over here, if the input is x plus h, then the output is f of x plus h. And we can connect the two dots with a line. So there's a line. And if you calculate the average rate of change between these 2 points, which is really the slope of this line, let's see what we get. So remember, the average rate of change is a change in the output over the change in the input. If you want to be a bit fancy, you could say, you know, delta y, delta means change in, y means output, over delta x. And what you would do is you'd find the change in the outputs, which is just the difference between these two heights. So you would take f of x plus h minus f of x, which looks like the same thing we have in our numerator right here. And then we would divide by the change in the inputs. So the change in the inputs, where you go from x to x plus h, to find the change, you take the difference of these two things. And so you take x plus h minus x. And what you want to notice is that the x's here, since you have x plus x and minus x, they actually cancel, and you're left over with just an h in the bottom. So really, these two things, these two things right here are exactly the same. A change of output over change of input, change of output over change of input. You usually don't see the x's though, because they always cancel. So we normally we won't write these things because they cancel. Right? Just like here, you could just rewrite this because they cancel, x minus x. You just rewrite this as f of x plus h minus f of x, all divided by h. And so we call this the difference quotient, and it's really a generalization of the notion of average rate of change. And what it's actually used for, if you think about this, if you look at a graph, you can argue a point, or argue that at every point there exists some sort of unique line that just kisses that point. We call it the tangent line. So right here, right, that may be called the tangent line. Whereas at this point over here, the tangent line would be quite different. You can see that there's a line that just kisses that one point in one spot, and so the slope of the tangent line here is steeper than the slope of the tangent line there. And so it tells you basically how it's increasing. Is it increasing quickly? Is it increasing not as quickly? And so on. Basically, it tells you the rate of change at that point. And that's what we do spend a lot of time in calculus. We talk about how do we find the rate of change at various points.